Hi everyone, this is our first day of a brand new unit. We're going to be talking about sinusoidal functions. We're going to graph them, we're going to analyze them, and we're going to use them to solve problems. Here's a great little picture down here of some of the stuff we are going to use, like period and phase shift, amplitude, and vertical shift. If you take pre-cal as well, you'll notice that this is going to be a repeater topic. But we're going to do things from a bit of a different perspective, and unlike pre-cal, we are going to use your graphing calculator, of course, because that's what this course is. So we're going to do things from a bit of a different perspective than you would do in pre-cal. So you'll definitely notice the overlap, but it'll only help you, okay? All right. So let's start with 8.1 here. A new vocabulary is something called a radian. So let's just write this down, then we'll talk about it. A radian is a unit of measure for angles. Up until this point, you've probably used degrees as how big an angle is to tell that a unit for angles. But another one is radians, and they can be really helpful. Uh-oh, I've got a sneeze coming on. So just for your information, 1 radian or 1 rad is roughly equal. That's why I put this little. It's not exactly. It's just roughly 60 degrees. So 1 radian is about 60 degrees, but the weird thing about radians is that we often use pies to help us figure it out. So we're going to draw ourselves a picture here, kind of comparing radians to degrees. And personally, when I was first learning about radians, I had a really hard time wrapping my mind about what a radian is. And it's just another form of degrees, like kilometers and miles are similar, degrees and radians are similar. All right. Now, a lot of the things we're going to talk about are going to revolve around circles or circular events, as in something happens and then something happens again. The same thing happens again. Like you're bouncing up and down on a bed. You get to the top height and then you get to the top height again, and then you come down and you come back to the top height and down and back to the top height. That keeps happening over and over and over again. So we often use circles to help us denote this. Let's split this up into some parts. Those are the 4 quadrants. And typically we start over here, because if you think about the quadrants, that would kind of be, 0. And then we go this way, which feels a little counterintuitive, but we go to the left. So this would be 0 degrees. How many degrees would be up here? That'd be 90. If I went like this, it's like me turning directly around, that'd be 180 degrees. And then keep going, 270. And then if I went all the way around the circle, that would be 360 degrees. Now let's do, let's do halves. What is half? Halfway between 0 and 90, well, that'd be 45 degrees. 45 plus 45 is 90. Plus 45, 135 degrees. I'm just going up by 45s here. So that'd be 225, 315, and I'm back at 360. So this is me just splitting this up into 45-degree angles. Now let's try and do the same thing, but in radians. Now this is not something I'm going to ask you to memorize. If you're in pre-cal, you're definitely used to this. I would probably put it on my study sheet and I'd leave it there. I'm not 100% sure you're going to need this in the future, but just in case you do, we got it. So, radians, we're going to start over here, 0 radians. Just the same, there's no angle, like you have no angle at all. The equivalent to 360 degrees is 2 pi. So, oops, I almost put down 360. 2 pi. So I'm just going to write that down up here. 360 equals 2 pi. Now, sometimes with radians, we don't bother to put down radian. We just put 2 pi without a unit, and that's just how we write it. So whenever you say degrees, you must have a degree, but in radians, you don't have to write down rad or radian after it. So, started at 0, we went all the way around, we got 2 pi. What would halfway around be? I think that'd be 2 pi divided by 2, which would be pi. I put a comma, not because I'm going to put another one, but just for the 2 things. Okay, And then what would be half of that? What should go right here? Well, that would be pi divided by 2. And we're going to say pi divided by 2. Okay, so let's count up by halves. Here's half a pi, 2 halves, which is 1. 3 halves. So 3 pi over 2, or 3 pi by 2. And then 4 halves, that would get us back to 2. Now let's count up by these smaller pieces. What is halfway between 0 and a half? A quarter. So pi over 4, or a quarter of pi. So let's count up by quarters now. And I know fractions are everyone's very favorite thing, but I promise we're going to kind of talk about this once, and then we won't really talk about it too much more. So if this is putting you off, don't worry too much about it. So a quarter, 2 quarters is a half, 3 quarters, so 3 pi over 4. 4 quarters is 1, which is great. 5 quarters, 5 pi over 4. 6 quarters, I think that can be reduced to this, that's great. 7 quarters. And then 8 quarters, we're back to 2 pi, we're done. Beautiful. So that kind of gives us an idea about how to look at radians in terms of pies. We're going to now work on converting a bit. Now I know converting is everyone's favorite topic. Let's try one just over here for a sec before we kind of get started. Let's add this in right here. Convert to degrees. Now you're going to have to think back to our very first unit, which was design and measurement, where we did a lot of converting. Let's say I had 3 radians, and I just put in rad, so we're not worried about, we're not confused about what unit it is, but normally we won't even write down the rad part. So this is my question. Convert to degrees, 3 rad. Now reminder, this is how I do it. If you want to do it a different way, you go right ahead. I multiply by what I call a conversion factor. And I totally made that up. I don't think that's a real term. That's just a term that I think of in my head. And I think to myself, this is in radians, and I would like it to be in degrees at the end. So where should I put radians so that it will divide to equal 1? Well, it should go at the bottom, right? Radians. And then degrees should go on top, so that when I multiply this straight across, the radians will cancel out, and we'll be left with degrees. Okay, now, how many degrees to how many radians? Well, there are 360 degrees to 2 pi radians. So, using my calculator here, I'm going to go 3 times by 360, and then divided by 2 pi. But we're going to be really careful when we put this 2 pi in our calculator, because if we just say divide by 2 pi and that's it, it will actually multiply by the pi, because your calculator is not actually that smart. So what we need to do is put brackets around that. Or divide by 2, hit enter, and then divide by pi, hit enter, because or else it'll end up multiplying. So give this a shot, please, and make sure you get the same number that I do. 171.89, need the unit, it's degrees. So 3 rad, not using any radians, not using any pies or anything, but just 3 rad, is about 170 degrees. Okay, let's try going the other way now. Let's find some degrees. I'm going to do maybe just one, and then I'll ask you to do the rest on your own. 45 degrees into rad. Let's see. So I'm going to start off with my 45 degrees, multiply by my conversion factor. This time we're starting with degrees, and I want to end up with radians. So degrees is on top, degrees should be on the bottom in my conversion factor. Because then when we multiply straight across, we'll have degrees divided by degrees, which is 1 unit, and that's it. And then it cancels it out. And I'm going to use quotation marks because I don't really like that word, cancels. Okay, and then rad, I guess, should go on top. So there are 2 pi rad to 360 degrees. This time we're going to go 45 times 2 pi and then divide by 360. This time we don't have to worry about the brackets so much, but if you want to throw some brackets in there, you go ahead. And I got 0.79 radians, which kind of makes sense to me because I knew 60 degrees is about 1, so 45 would be less than 1. That's pretty reasonable. Try the rest of them. They get pretty repetitive, the same idea over and over again. We can convert. Let's try this one down here. Let's estimate, and then let's continue on. Maybe let's do this one, because that one's kind of easy. Let's try this one. All right. Here is my angle. I started here and I went this way because that's what this little line is trying to tell me. I'm looking at this big angle, not the little guy. Let's try and guesstimate just in degrees how much this is, and then we'll convert to radians because it's hard for me to think in radians because I'm not used to that one so much. So I'm just going to add some stuff here. I figure this is 180 degrees, right? Like that's straight across. And then this would be, well, that would be 180. That'd be 270 degrees, right? So I'm kind of somewhere between 180 and 270. I'd say maybe this is like 60 degrees. Just kind of guesstimating. No perfect answer here because I'm not going to measure this. That's silly. So I'd say the whole thing is probably 180 plus 270 plus 60, I'd say that's about 240 degrees. If you think something slightly different, that's totally okay. And then let's convert this to radian, and I'm just going to straight up convert. I'm not going to try and guess what that is, because converting is easier in my opinion. This one I didn't do ahead of time, so I'm going to type it in. So 240 times 2 pi, oh, P.S., pi is right here on your calculator, so I have to go second, and then that pi button right there, so it's blue in my calculator. And this is roughly 4.19 rad. Certainly not perfect. I could probably measure it and it'd be something a little different, and that's totally fine because we're just estimating here. So try this guy and this guy, see how it goes. You'll notice that this one is it's past one full circle, right? It's one full circle and a bit. So that one's a little trickier. But give it a shot. Let's see how it goes. All right. Here's 8.2. Let's talk about periodic functions or sinusoidal functions. They're related. They're not exactly the same word, but they're related. All right. Now, knowing myself, I have terrible writing. I'm going to use all this space. I'm going to have to crunch it in just a little bit. Just knowing myself. Okay, so first things first, here's a bunch of new vocabulary. This is great stuff to have on a study sheet. And we're going to make a picture down here. So this picture is probably the picture. Like this kind of wraps all this stuff up, okay? So, you know, this is really good study sheet stuff right here. Okay, a periodic function is something that repeats itself. So it does something, it takes a certain amount of time, and then it does the exact same thing over again. So maybe days of the week I could graph when I get up, when I go to bed, when I go up, when I go to bed. Like the exact same thing happens every single day, what I'm doing. So a function whose graph, don't know if I used the right who's there, but that's okay. We're not in English, repeats itself in regular intervals. In regular intervals. So if it takes 6 seconds to do something, it always takes 6 seconds to do something. It's not changing its mind on us. So if I were to make a little example, this is a periodic function where it keeps doing these spiky guys forever, or for a while at least, but it's beautifully symmetrical. It does the exact same thing over and over again. It takes the same amount of time to do it. Okay, midline. Midline is a horizontal line that's kind of halfway in between this thing. And P.S., if you take physics, you'll definitely be talking about these things there as well, especially when you're talking about waves. So the midline is the horizontal line halfway between the min and max. We'll talk about what min and max are in a second, but you can probably guess. The minimum point is the smallest y value. The maximum point is the largest y value. And there's typically more than one of these things. There's often like infinite numbers of them. So if I were just draw a tiny little picture over to the side over here, let's say this is my graph. A midline would be beautifully in between those going horizontally. That would be my midline. It's pretty hard to see, but it's just beautifully in the middle. We'll do a better picture down here in a second, just to graph that out. Alrighty, amplitude. Amplitude is like, how high is this graph? What's the height of it? So it's the height of the function. Height of the function, and usually how we measure it is we go from the middle to the top, or from the middle to the bottom, and that will be the exact same height. So if it's 2 meters up, it would be 2 meters down, and we just call it positive 2 meters. A is typically a positive value in how we think about it this way. So the height of the function from the midline to the max slash min. Either one, it should be the exact same value. Okay, maximum. This one's easy. The highest y value. And there's typically more than one. For example, right here, there's a max, there's a max. Minimum. The lowest y value. Again, often more than one. I just drew one on here, but there'd be another one kind of down here, and then another one over there, and keep going. Just the highest value, then the lowest value. Nothing crazy there. Period. Here's some new topics for most of us, a new term for most of us. The period is how long does it take for this thing to start to repeat? So in this one, I need to think about where does it start over again? Like right there, that's where it would start over again. So this x distance is my period. How long does it take for the cycle to restart itself? How long does one cycle take? How long, just to say it another way here, how long does it take to repeat? So sometimes you look at a value and you just try to find where does this happen again? Where does it look like the cycle is repeating? It's not always that we start at x equals 0. Sometimes I'll look at this point. I'll be like, oh, when does this point happen again? Okay, we go down, we go up. Oh, there it is. And then it's this x distance, not going all the way back to the y-axis, but we start here and we think up to there. So sometimes we have to do that. Alrighty. Last one, phase shift. This is everybody's favorite topic. It's kind of like the horizontal shift. Like how far have we shifted to the left or the right compared to what we're kind of expecting. Actually, I should just mention here, period equals 2 pi over b, or if you're in degrees, 360 over b, and we'll come back to that a little later. We'll talk about that another time. Okay, well, later today, and then tomorrow. Okay, phase shift. I'm just going to move down here. Phase shift. It's how far the function is horizontally shifted. Shifted, like how far is it moved to the right of its, I'm going to say left, right. You'll see what I mean. Of its original position. And that's the C value, but we'll come back to that later. So for example, let's say that this was my original graph. And then I did this, where it's the exact same graph, But I took this graph and I just moved it this far. That would be my shift. I just took it and I moved it to the right. So I'm saying like I've shifted it to the right, and whatever this distance here is, that would be my phase shift. Okay, that is that. Let's try and put most of these things on a graph down here. And this is basically the graph you'll have on the front page, but it's nice for us to put it together so you have an idea of kind of what I'm thinking here. Try your best to draw this, but if it's not perfect, well, that's all right. Just a curve. I try to make it as symmetrical as I can, but sometimes it works out better than others. Like this one, it kind of messed up that first curve right there, but we're not judging. All right, so let's start off with the easy stuff. Actually, let's start at the beginning. Let's just work our way down here. Midline. That is a horizontal line right through the middle here. So sometimes I draw it with a dotted line because it's really not part of our graph. It's just something we look at. I also didn't do it perfectly here, did I? But that's okay. This is the midline. There should be the same distance here as down here. I kind of missed, but I'll forgive myself. Amplitude. Amplitude is the distance from this midline to the top. However big that is, like 4 units or 2 units or whatever. And it's also the same distance down here. 4 units, 2 units, whatever it is. It'd be the exact same. Mine's a little skewed, but that's okay. Next, maximum. Here is a maximum. Sometimes we call it a local maximum because it's kind of the maximum in this area. And then, hey, here's another maximum over in this area. All right, well, that would make this the minimum, the highest and lowest y values. Oh man, I gotta sneeze, but it's not coming out. That kind of sounds gross, but that's okay. Okay, period. Here's everyone's favorite right here. I think I'm gonna use pencil just so I make it look a little different. Period is how long does it take to repeat? The points you can look at are maximums. How long does it take to go from one maximum to another? Do you see how in this time period we've gone through one full cycle? So from here to here is 1 period. Or another point we could look at is the minimum. I'm just going to add it this way here. Here's another minimum. We could look at how long does it take to go from one minimum to another. That is 1 period. If that's 10 seconds, this would be 10 seconds. It's exactly the same. One more place is the midline. I mean, there's lots of places, but these are some good ones. So right from here on the midline to the next, I kind of skipped a midline point, but right there, that is also 1 period. So that would also be 10 seconds. Because this thing is beautifully symmetrical. We can look at a lot of different places for period. So it just kind of depends on what you're given. Depends on what's easiest to see. What doesn't make you have to round stuff. That's probably what I would look at. So let's try and find some of the values down on this graph down here. We'll see how it goes. I'd like to find the midline, the max, the min, the amplitude. I'm just going to amp just because I'm lazy, and the period. Okay, those are the things we're going to try and find. If you want to try and find them on your own right now, that'd be great to pause and give it a shot. All right, I'm going to get started. Midline. That's halfway between the bottom and the top. Well, the bottom is -1, the top is 1. So that's a distance of like 2 y values. Halfway between would be 1 y value. We can see it pretty easily right here, can't we? It's right on this line. Y equals 0. Now this is really important that this is a line. So we have to say y equals 0, or y equals 1, or y equals 2, or whatever it is, but y equals. That's very important because it is a line. It's not just a point. Okay, maximum. So this is just a y value we need. We don't really need the x values. So there's a max, there's another one right there. Y equals 1. So just 1. That's the maximum point. Minimum, down here, -1. Amplitude. Distance from 0 to 1 would be 1, or 0 to -1, still 1, good. Period, this one's the hardest one. Now, I apologize, this graph is not beautiful because I have to kind of guess what values they are, but I'm just going to do my best. Let's see here. I'm just going to erase so I can see this a bit better. I'm going to call that 1.5 just for simplicity. I apologize if you disagree with me on that value. We're just gonna keep it easy here. Actually. So we could look from maximum to maximum, but that's kind of off the graph, so maybe that's not a great idea to look at those. Let's look from midline, not there, because that's not one full period yet, but up to there. So from here to here, let's look for midline, or for period. And how far do you think that is? That's maybe like 6.3? I'm guessing. Yours is going to be more clear when we do assessments, but let's round it to 6.3 right there. So 6.3 units, since there are no units on here. I think I wrote in my notes here 6.2 units. I kind of guessed. You know, it's all good. So we're just looking from 0 up to 6.3. We could have looked at the maximums here, and that's about 8. So I'd go 8 minus that 1.5, so about 6.5 is what I would have guessed if I was doing the maximums. They should be exactly the same, it's just because I'm kind of guessing as to what the value is. Alrighty, and that's it for today. Here's your homework, page 519, number 1, just A and B. They get really repetitive, that's why I don't want you to do too many of the exact same thing. So just give those parts a try. If you feel like you need more practice, certainly try the rest of the parts. Otherwise, have a great day.